This conference will now be recorded.
Hi, welcome back. So we had a few days gap. Our last session, we deployed this our RoboShop microservices application into Kubernetes cluster (EKS), and at the last stage, like the payment, we got some error. So that error is related to instead of user host, I gave a cart host. Okay, so this should be user host. This is a new cluster I just provisioned right now. And let us quickly set up these things from the back. First, I'll set up this database, and then from the back, I'll set up all the services. Finally, web. Then we can directly access the browser. This will take maximum 10 minutes. Let us set up quickly. This is RabbitMQ, right? So we have all the things are here. Just creating a duplicate session. K9s. Start utilizing this K9s tool. This will be very good. Okay, so here first RabbitMQ, apply manifest, and then what is the next thing? MySQL, MySQL, apply manifest. Let us see the pods are coming up here or not. Yeah, coming up. After that, Redis, MongoDB, Redis, MongoDB. Okay, let us see all our pods are getting created or not. RabbitMQ is running, remaining are all getting created. Okay, and finally payment. Let me do this change. This should be user underscore host. Okay, workshop. Oh, sorry, should go to payment. Okay, all state database related things came up. Now let us go to payment. Create pull, apply manifest. Okay, payment is coming up. After payment, shipping. After shipping, it is user. After user, it is cart. After cart, it is catalog. Okay, so all backend and database are ready. Now you can see how fast it is to set up the microservices application into Kubernetes cluster. Finally, web. So this web will create one load balancer. We need to use this load balancer to connect. If we go and check here, load balancers. Mm, Out of service. Yeah, coming into in service. Okay, now let us access this. Login. Maybe this is new cluster. I need to register first. After register, add to cart, checkout, shipping is working. Pay now. Error placing the order. Now let us see this. Why this is error? Go to payment pod and check the error. Name or service not known. Which name or service not known? Hmm, This is the payment information we sent. Here is the error. Let us see what is this 192.168.52.92. 58.92 or 52.92. Payment. One 192, 168, 52.92. Let us say this 52.92. This one. Web. This is related to web. Let us go and check inside web the configuration. For payment, it is correct. From payment, it is not able to respond to the web. Name or service not known. Same error. Okay, let us take the shell of this. Curl user hyphen svc. Cart host, user host, AMQP host. Let us see AMQP is connected. RabbitMQ is connected. There are no errors. payment, RabbitMQ, payment is connecting to user, payment is connecting to cart. Mhm. Slash post. So something is error in this slash pay. Let us see what is slash pay. Yeah, here in this code, so no, you not to worry about this because you set up from your side, but these are like development adjustments. You no need to worry about this. Hmm. Here still there is some port number 8080. So it is okay. This is 8080 only. This application is opening 8080. Hmm. The error is coming here slash pay. This is the API slash pay slash username. This is the username, and it is trying to post the payment information to this. Then it is getting error. So here this service, if you do what it is doing is payment for check user exists. It is hitting the user. It is the user host. User underscore host. Let us see whether that is exist or not. Take shell env grep user. Yeah, user underscore host is exist. User svc cur user svc colon 80 slash check slash siva. Okay, so the response okay, and after that this is payment gateway. After payment gateway generating the order ID, posting the order information to user, and after that posting the information delete cart. This delete request. That's all. Mm, so last time I tried queue order. So this is done queue order. This is done, and this is getting error actually from here, either this one or this one. Either delete cart or this one. Hmm. Error. There is no exact error here. Shit. Hmm. Anything I'm missing? Simple thing. Okay, let us log out and then check again. Adding to cart. Checkout. Now same error, name or service not known after queue order. Okay, I'll take 5 more minutes. Up to this point, this is done. After this, it is posting to user. Let us see, we got the logs to user. So we got some request here. From user, it should go to the cart. Cart, we got something. Two 732. Okay. But after that, no delete request. Something in the cart. enp grep cart. Cart is okay. Cart hyphen svc. Okay, let us do one more thing. I will get the user logs. And then we will see here we are getting this order information or not. Slash order. Okay, I will check out. There is no URL coming up with slash order. So this is not working. There is no URL slash order. Okay. Shell curl http user hyphen svc slash order slash id. Okay, so this is post method, so we are getting this error. This is also fine. Yeah, we got the order information here. You can see this, but it is saying 404. Okay, slash orders. Let us check in user. Slash order. Here database not available. What is this database? So user is connecting to Redis and then MongoDB. Those spots are available, right? Redis and MongoDB. Okay. Let us get this log and then check thoroughly what is going on. Four not four. Four zero double nine two. What is this? 40992. There is something wrong here. This is happening here. It's connecting to MongoDB to find the users. DB. Okay, connecting to DB, MongoDB only. I'm not sure why it is connecting to 40,992. Okay, so I will just dig it into more after the class. Okay, just think this is completed like earlier. A small error is stopping us. I don't want to waste time in this for more. Tomorrow I will tell you what is the real error. But definitely this is not something from our side. Maybe some small communication between one pod to another pod. I will check this. Now let us go to the next topic of Jenkins. I will explain the architecture, how it should work first, and then later we can implement it. Okay, usually there will be a Kubernetes cluster running here. Kubernetes cluster, and we will have Jenkins outside of the Kubernetes cluster. This is like normal VM. And we should have, this is like Jenkins master. Generally, we can have slaves, again, same like VM. This is Jenkins slave. There will be multiple slaves. Like this is one slave, this is another. So you can use this slave, first slave for Java projects, second slave for Python projects, and third slave for Node.js projects. Okay, for example, this is Java, this is Python, this is Node.js. So whenever you run some job here, Jenkins will connect to these slaves. So this is the normal architecture. If suddenly you got 100 jobs, then these architecture cannot support that. Okay, because you have only 3 slaves. One slave cannot handle 30 jobs at a time. Maximum it can handle 2 or 3 jobs. Okay, so in that case, what we do is we will spin up the pod into the K8 cluster. This is the Jenkins slave pod. This will connect from here to here. This will complete the pipeline and this pod will be terminated. This will complete the pipeline and this pod will be terminated. So if you get 100 jobs at a time, there will be 100 slaves created, like 100 pods here. You can see how small these are, our pods. Within seconds, these pods will come up and then connect to the Jenkins, and it will do the job and terminate it. You have the logs available in the master. So that is the good concept we can do with Kubernetes cluster. Whenever somebody asks you how you use master slave concept of your Jenkins or where you use Docker, then you can say we have Jenkins master running in VM, and the slaves of Jenkins master will be created as pods in our Kubernetes cluster. We will maintain those slaves. Okay, so this is the nice answer you can give. And this is the best implementation as well, because you no need to maintain the slaves like this here. You're just running it and then deleting it. So you can set up any number of slave pods based on the load of master. Any doubts still here? Gopi?
No, sure. So master slave,
Okay.
I'm currently using this one.
Oh, nice. So the same setup you are using?
No, not in Kubernetes, but this setup is I'm using.
Oh, this one, like VMs.
Yes, like VMs I'm using.
Okay, so now let us see this setup. This is everybody knows, and then everywhere it is implemented, that is common. We'll see this
Yes.
setup. So this Jenkins master is connecting to Jenkins slave, and it needs to authenticate the Kubernetes cluster. Here authentication is very important. So till now we will see what authentication we used. The authentication we used is mostly like admin. For example, now I have the Minikube cluster also created just before the class. Let us get the configuration. scp-i kubeconfig copy to /cube/admin. Now let us see this. What is the configuration we have? How can we authenticate? Let us take this. Yeah, so there is cluster. This is cluster authority data. This is like public certificate of the cluster. This is the cluster server URL, and just name, this is okay, whatever you can give, and the username is admin, and you can see here this is admin certificate data and this is client data. So in Kubernetes, the authentication works on the certificate mechanism, not like username password. This is like certificate. You have to send your certificate and the private key. Same like how HTTPS works. HTTPS will send a public certificate to the client browser, and browser will verify whether the certificate is valid or not. Then uh, it will it will encode a small text with that certificate, and the other side server will decrypt it with the private key. So that is the HTTPS authentication mechanism. Here the same thing in Kubernetes also, it maintains the certificate and the private key. You need to pass this information to the Kubernetes cluster, then it will understand your rights and whatever the permissions you have. Since it is admin, we got the full access. Now we cannot give the admin access to this Jenkins. Okay, so now what we do is the steps. Let me write down the steps. Create a namespace for Jenkins. Okay, create Jenkins user. Assign permissions for Jenkins user to Jenkins namespace. Okay, and then create kubeconfig file for Jenkins user. So this is called as RBAC, role-based authentication, role-based access control. Okay, role-based access control. So first let us create a namespace, and then let us create this certification mechanism like this. Okay, so for that, let me create a folder called Jenkins. Here, Jenkins user.yaml. Okay, so first we need to create the user. Let me do SSH. Okay, let us log into this Minikube. Okay, I'm in Minikube server. Okay, I'm in Minikube. So the process of creating the user is create a key for user. Everything here is using OpenSSL command. Okay, and then create certificate signing request called CSR for user, and sign this certificate with Kubernetes CA private key and public key. Okay. Sign the certificate with Kubernetes CA private key. This is the process of creating the certificate signing request and then getting it signed from the CA authority. If you go here and then check cd/, cd/etc Kubernetes and PKI folder. Here there will be your Kubernetes CA certificate and then certificate key. Okay, you should use these two things to create a user. So obviously this has access to the admin only. Only they can create these users. Okay, now let us create one user. I'm just creating user called, okay, let us create user called Jenkins. Let me see with our user and later we can create it for Jenkins as well. Okay, so here this Siva only wants to need access to the RoboShop namespace. Open SSL gen RSA hyphen out siva.private key. So these commands I will post. These are like standard commands from OpenSSL. So you have your Siva private key. You need to create signing request. OpenSSL request -u -out. The name should be siva.csr and then key is siva.key and the signing CSR information is like this. This is important. CN. This is going to be your username. Slash O means organizational unit. I am giving it like something for now. There is some importance for this. We will see that. Okay, you got your key and then CSR. Now there is a command OpenSSL sign CSR with CA key. I just got it from internet. I cannot remember it. That is OpenSSL X 509. This one. Okay. OpenSSL X 509 and then okay, this is self-signed. We need CA signed. This one. General command will be there. Like this. Okay, open SSL X this one and then hyphen request. Input is siva.csr and then hyphen CA slash etc slash kubernetes slash pki ca.crt and then hyphen CA key slash etc slash kubernetes pki ca.key and then this one create serial siva.crt hyphen how many days it is valid. It is valid for 500 days, this certificate. We are nothing giving, inputting our CSR information and then signing with CA certificate and then CA key and generating a certificate file for us. Okay, so we got this Siva CRT, Siva CSR, Siva key. Now let us create a kubeconfig file. I'm just creating a kubeconfig file. This is certificate authority data of the cluster is same, server is same, and here user is like Siva. Name, you can give any name actually, but whatever name you can give here, you have to use it here same. Okay, our cluster name, I name it as Kubernetes. This user is Siva, and then the context name is Siva@Kubernetes. Current context is Siva@Kubernetes. And then name is this one. What is the client certificate data? So that is this one. Cat siva.crt. You need to base 64. But this is with the new character, I mean new line at the end, wrapping. So I need to give wrapping as 0. No need of wrapping. Everything should be in a single line. So this is the single line. This is client certificate data, and we need client key data. Let me remove this first. Okay, I'm saving it here. Siva-config. Similarly, client key data. Cat siva.key base 64-w0. This is the key information. Okay. Now just set kubeconfig equal to siva-config. Now you see kubectl get pods. You can see Siva cannot list. It means the authentication is success. First, the authentication is success, but while checking the authorization, user Siva cannot list resource pods in the default namespace. Okay, because we don't have permissions. Now, how to create that permissions? First, let us create the RoboShop. Just think like we are RoboShop users. Namespace ML. So we are creating a RoboShop project and we need to give authentication. We cannot give admin access to that particular RoboShop users. Now this is RoboShop namespace, and after that, here it is called role. Role means permissions. What are the permissions you are giving in Kubernetes? If you say Kubernetes role, there will be a good documentation called Kubernetes RBAC. Kubernetes role based access control. First, let us create a role. Now assume this Siva is a developer. I need to give only read access to the Kubernetes cluster because DevOps guys will have the write access. Developers will only have the read access. So this is called as RoboShop reader role. This role will have core API group. Here API group, resources and verbs. Resources means there is resources like pods, deployment, services, stateful set, and lot of other resources. Verbs means what we can do on those resources. This is like read, getting, watching, and listing. Write means create, update, delete. That is the write access. Okay, these three things defines the role in Kubernetes. API groups, what are the resources in those API groups, and what are the verbs. The API groups we have like V1. V1 is the one API version, and there are multiple other API groups. We don't need to know much of this information, but the hierarchy you can say is, I'll take 10 minutes extra today. This is API group. In API group, you will have resources, and in resources you will have verbs. Okay, or you can do something like this: API group, resources, and verbs. Okay, now this is creating a role with permission for the RoboShop namespace, pods, reading the pods access. Okay, so after you create role, you need to create role binding to attach this permission to the user Siva. Okay, so let us take that role binding here. So you can see syntax is same for every Kubernetes: API version, kind, metadata, namespace. What is this namespace? RoboShop. And the name of this role binding, you can say RoboShop reader itself. These things will be created by cluster administrators. Now you are attaching this role to the user Siva, and the role reference, what role you are attaching? RoboShop reader. So this is very simple mechanism. Just everything you are maintaining inside AMLs. You are attaching this user to this role. That's it. Okay, now let us push this to our Kubernetes cluster. Hmm, okay, so for this I need to use admin config because I'm administrator now. kubectl apply -f Jenkins user. Okay, user got created, and then reader got created. Role binding is also created. If you see kubectl get role in a namespace called RoboShop. Okay, you can see the RoboShop reader got created, and role binding also you can see. Okay, role binding is also created. Now you can just give kubectl get pods. This is going to default, but if you give -f -n RoboShop, you can see now you are not getting error. You are just getting no resources found. Okay, if you simply push some pod here, then you can get it. Let us simply push some pod, API version v1 kind pod metadata name demo spec containers name demo image nginx. That's it. Let us push this. Kind not set up. API version, kind, metadata, name, spec content. Anything is missing here? Okay, this should not be the capital one. This is small one. Okay, now you list down the pods, you will get it. This went to default namespace. Let us send this to RoboShop namespace. Okay, you are getting. But if you try to check the services, you will not able to get it because you don't give the service access. You didn't give the services resource here. Now if I give services, I'm changing the permission. Now you need to push. Now the error will be different. No resources found in RoboShop namespace. Okay, any doubts still here? Ravi, Abhishek, Gopi. So you understood this concept, RPAC?
Yeah, concept is okay, but we'll see one more time. We'll see the
Yeah.
record.
So yeah, tomorrow we will anyhow discuss more. Now this is user. But what if you have 10 members in the development? You cannot go and give access to every user, right? So the common best practices is you create a group and assign permissions to this group, add users to this group. So this is the common best practices in any technology, right? Okay, so we will discuss this as well tomorrow. And then, so in real time, generally what administrators will do is they will create a namespace called RoboShop, and they will create a groups like reader group, namespace admin group, and writer groups like DevOps, for example. This will only have read, this will have minimum write access, and administration can do anything within that RoboShop namespace. And you add users to this group. So for example, if a new developer added, you just add this user to here. Okay. So once we understand this, then we will go and create a Jenkins master and then run slaves in Kubernetes. Okay, once we see this is normal Kubernetes, but EKS is a little different. We can see that as well. So once these topics are over, now later we can go into the sending the logs of the pods to the Elasticsearch cluster and Helm charts, operators, all those things. Okay, if no doubts, that's all for today's session.
Shiva, one more doubt.
Yeah.
So if you are doing any project, I mean, if you want to create infrastructure like VPC, subnet, all those things, and I want to create a cluster inside the infra, so how can we do that? I mean, currently we're using only one command.
Yeah, so that is like for in projects, the VPC should exist first. And after that VPC is exist, then only you can create the EKS cluster. Usually no one will create that VPC with including EKS. Okay. So this is for our practice purpose. If you have the VPC already created, then you can refer the EKS CTL documentation. There you can give your VPC ID and which subnet your EKS cluster wants. All that information you can provide there.
Okay.
So inside this config file we have, right, EKS config file. So there will be a simple, so here like this, you can provide the VPC configuration, EKS CTL VPC configuration. Here you can provide your which VPC, which subnets you want. All those information you can provide here. So then EKS CTL will create a cluster inside that VPC. Okay.
Okay.
Okay, then that's all for today. See you in tomorrow session. See you. Bye bye.